Good afternoon, everyone. Can you see us? Can you hear us? So, if you can hear us and see us, so just raise your hand from the dialog box. Yeah, Ajay sir, I hope you can see me.
I'm not able to see you, but I'm able to listen you properly. And I hope
Okay,
my
okay,
voice
that's
is
good.
also loud and clear.
Yes, yes, very much it is. So, yeah, again, I'm welcoming you all to our session, which is based on online training basically for the Fisher XRF machine. This session includes 3 to 4 agenda. Actually, the topic of the session is for having a basic idea of the XRF machine to get to know what exactly the science behind the working functionality of ED-XRF machine, and you can also explore the kind of application you can do in our XRF machine. And at the end of training, we can also give you some insight of for the online software training about our WinFTM software training, which is going to be given by Mr. Ajay Raina. So yeah, I think we should start our session. It's already 1 minute past, so I won't want to take your much time since we are already have our lunch and started this session. So yeah, over to you without without killing any time of yours. I'm handing over this seminar or webinar to Mr. Ajay Raina. I literally introduce first Mr. Ajay Raina. Mr. Ajay Raina is basically based in Pune, which is our head office in Pune, Maharashtra, and he's taking care of the application part, and he's basically an application especially for the all Fisher XRF range of machines what we have. So all the application and product related queries he resolves, and he's the expert of all our machines. So yeah, Ajay Rana sir, it's all over to you. You could take ahead this webinar by your end. Yeah, over to you, sir.
Yeah, thank you, Yogesh. Thank you for a kind introduction. Thanks a lot. Yeah, hi. Good afternoon, everyone. I hope my voice is loud and clear and you are able to see my screen as well. So we can start. As you know, most of you are our customers as well. The Fisher is mainly involved in coating thickness instruments, and we have different range of instruments based on portable DFT instruments, ED-XRF, colorimetric materials testing methods, and nanoindication system. In portable DFT instruments, we have manual ignition method. Uh, Manual ignition method is for checking in case you have a coating, you have non-magnetic coatings on ferrous base, then you can use manual ignition method for checking the coating thickness. We also have eddy current method. Eddy current method is used when you have non-conductive and non-magnetic coating on electric conductive base. So we have both the type of applications. We can do manual method and eddy current method. Then we also provide the solutions for phase sensitive eddy current method in case you have conductive coating on ferrous base. That is, in case you have nickel coating and base is again magnetic, then you have to use phase sensitive eddy current method principle for checking this type of applications. And then we also provide the solutions for checking the copper coating on PCBs by using 4-point resistivity method. Then comes to the today's topic, that is ED-XRF method. We have wide range of instruments in ED-XRF, top source, bottom source, and handle type of gun type of instruments. We will discuss it in the future slides. Then we have colorimetric instruments for checking the step test in case you have nickel step in your applications, mostly in decorative coatings. If you have a chrome nickel step on copper on ABS base, then we can use CMS step for this type of applications. This is a destructive method, but yeah, in case you have applications where you want to measure a nickel step, then we can choose this instrument for your application. Then coming to the metal testings, we have farad content instruments. We can check the farad percentage, we can check farad number. Then we have electric conductivity instruments. we can check the conductivity of the non-magnetic based samples. We have surface profile thickness gauges where we can check the profile of the samples. Then coming to the other portfolio, we have nano emission systems where we can check the thickness of hardness of the coating. If your coating is say approximately it is greater than 1 microns, we recommend you to go for the nano emission instrument. If it is less than 1 microns, then we recommend to go with a pico dentate instrument. So as already discussed, Fisher, starting from 1953, we are already involved in coating thickness instruments. So coming to the coating thickness gauge, we have all type of DFT instruments, including different type of uh, probes as per your requirement. In our product portfolio, we have approximately 150 type of different probes. We have angle probes, we have straight probes, we have probes for checking inside the bore holes. We have the coating. You can have the coating say approximately from 1 micron to 1000 mm or 100 mm. We can have the coating application solution for that. Then we also provide solutions for metallic coatings on any substrates. Then we can use XRF instruments, and we provide the standards, the calibrated standards, international standards from Dux Lab to verify your results. So from 1953 to 2022, approximately 67 or 68 years, we are only related to the coating thickness measurement instruments. From 2000, we have started nano indentation system for checking the hardness of the coating. We can provide you the solution for inline measurements, offline measurements, and we can use solution for industry 4.0 as well.
So
As per
basically,
today's topic,
what we have invented from 1953 to 2022, it is, I think, from starting to handheld, we are gone up to the inline measurement. So from the laboratory solution to your process line, we can give you the all kind of solution. And since if you can see all our product range in an entire slide, so I mean, by going through this slide, I think we can have clear understanding that our core subject is coating and plating thickness, in which we are very pioneer in this subject, and all our product range is around revolving around to cater this application of coating plating only. Yes, sir.
yeah, correct, Yogesh. And we Fisher in Fisher we also say if you have a coating and if Fisher says no, then no one in the world can do that application. 99.99% Fisher doesn't say no for any application. But yeah, in case Fisher says no, then we are 100% sure that no one in the world can do that application. Otherwise, Fisher has a solution for that applications.
So this is
Uh,
the technology on which customer can trust. We are global
yeah,
company. We are, I mean, what solution and what system we are delivering, it is best in the industry.
yeah. Coming to today's topic is, as already Yogesh has described in the beginning itself, today's topic is ED-XRF method. And Fisher has actually, we have a broad range of XRF instruments. We have approximately 40 different instruments, depending on your applications, depending on your requirement, depending on your sample size, depending on your voltage, what voltage you want for your sample analysis, what filters you want to choose, and what type of coatings you have. Yeah, as already discussed, you can see the images here. We have the instruments from proportional counter to SDD, and we can give you a single collimator or multiple collimators. We can give you a manual stage instruments where you can have to do the testing by manually. You have to place the sample, you have to move the sample manually to check the samples. Then we can give a programmable XY programmable stage instruments where you can program the you can keep a number of samples and you can program it automatically. And it's, you can say it's like an automation type of instrument. You have to just keep the sample and you can continue go on running the samples. And you can run one sample at in a single sample you can do number of tests. Then we have an option for you can choose the voltages, different voltages, you can choose different filters as per your requirement, as per your application. Then we have instruments with bottom up or top down depending on your application or your requirement. Then we have a special instrument that is a portable handle type of instrument, XRF handle instrument. which is you can make it as a portable ED-XRF, or you can carry it anywhere. Say if you want to, you have a big samples and you don't want to carry the sample to the lab, you can take your XRF instrument to your site and you can check it directly. Then, as already discussed, we can
Correct.
give you inline solutions also and offline solutions as well.
Yeah. So basically, sir, our ED-XRF machine, whatever with the 40 to 50 different models we have in ED-XRF, it is based on these some configuration that is SD based on detector. First thing, whether it is PC counter, SDD detector, or silica pin. So based on detector, it is bifurcated. Based on collimators, it is bifurcated. And based on the automation, like some models, what we have, it is manual. Some having some programmable automation is there. So, and some on most of the our range is bifurcated on the source, whether it is bottom source or top source. So all these 40 XRF is bifurcated on the basis of these categories, like top source, bottom. Some are top source, some are bottom source, some are programmable, some are manual, some are based on detector types, like some are proportional counter, STD detector, all these things. So yeah, definitely we will discuss all these detector parts, as what is SDD, what is PC counter, what is programmable, how it will, what is collimator. Definitely in coming slides, Ajay sir definitely going
Yeah,
to elaborate
yeah,
each and
yeah,
every
yeah.
topics.
And I
Yeah,
just I just
meanwhile,
wanted to add one more thing, that even if you have big samples and you don't want to check at site, we can design an instrument as per your requirement. We can have an instrument as per your cabinet requirement. Whatever, if you give us details of your sample, we can design your instrument based on your application. We can give a cabinet set of instrument where we can have either PC quantity detector, we can have a silica pin, or we can make a SDD as well, depending on the customer requirements and customer sample size.
correct.
Uh, Coming to the working principle,
Wherever, sir.
actually, sorry, yeah. Coming to the working principle, actually, EDXRF is based on a technique where we check the coating thickness and we can do the composition analysis. And the working is based on ASTM 568 and ISO 3497. Uh, this diagram what I have given is here. It looks like a little bit complicated, but it's very simple. The principle of the XRF is very simple, very easy to use. I just described this slide in the next one. So I'm going to the next slide here. So what happens when you have a sample and when we bombard the sample with the X-rays? So what happens? The radiation, the sample is getting excited. So when it gets excited, it gets ejected from the inner shell. So what happens? So the second shell, related to the next one. Say we have K shells, L shell, M shell, and N shell. Then the electron from the L shell or M shell has to come out and goes to the inside shell, insert shell. So I can show you the diagram here with the video. So what happens when we bombard the sample with the X-ray radiations? It gets excited and it comes out. So from the outer shell, from L shell or M shell, the electron which is having the higher energy comes inside to the lower energy. So coming inside from the higher shell to the lower shell, and it has to release this energy, and that energy is measured with the help of detector. And detector gives the information about the composition analysis, what exactly the material is. So if you see from the image here, we can get the information of the sample composition. Like if your sample is having gold, your sample is having copper, it is brass, or it is lead, whatever elements are present there, we can do it and we can check it easily. So I can just run it again so that you can have exactly what is. There's some bombarding X-rays on the sample, it gets excited and it comes out of the shell. Then the outer shell electron comes inside. So we measure the spectrum is detected with help of detector, and that is read with the detector and gives the information over the sample information, whatever the elements are present in the instrument, in the sample.
Okay. So if I can, I mean, what I understand, sir, from your briefing is that this is what the atomic level, if, I mean, if I'm putting some sample, like I have to check a gold coating on
Yeah,
MS or
yeah,
copper. So basically
yeah,
we put our sample under our machine and
Yeah.
our machine emit some X-ray radiation.
Yeah.
So the
When we
when X-ray radiation fall on the sample, so this is basically the atomic level things, what is going on the atomic level things on our sample. So this is basically for each and every atoms what is going on.
Yeah,
So
exactly.
it's
Practically, if you
pretty much
see,
related
if you
to
yeah, if you see that one, when you have a sample inside your XRF tube, it can be a gold sample, it can be any type of coatings. Like you say, you have a brass-based sample, and on that you have done nickel or you have done tin coating. So when I bombard the sample, the electrons whichever is there in present in the sample, so X-rays are hitting the innermost shell. So when it
correct.
gets energy, that electron gets ejected out, and that the space which is left behind, the vacant space in shells, you cannot leave a vacant space, so that shell has to be filled from the outer space, so that is filled with the outer shell. When uh, whenever the shell from the outer space comes inside, that has to release its energy because it is coming from higher range to the lower range. So that range we call as a secondary X-rays, and it is calculated with the help
Correct.
of detector. Yeah.
So basically, this phenomena of replacing one electron to one cell to another cell is basically the fluorescence effect, what it is, and that's why
Yes,
this
correct.
machine is named
Known as
energy
ED, energy
dispersive
dispersive XRF.
X-ray fluorescence, right? Because this
Correct.
effect
Yeah.
is
Normally we
basically the
called it.
fluorescence effect.
Yeah. Yeah. That's why we called it normally as a ED-XRF, energy dispersive X-ray fluorescence technique.
Yeah. So this X-ray energy is coming to the sample, and at atomic level, the innermost electron get excited by accepting the energy of X-ray.
Yes.
And that space which is created at the innermost cell has been replaced by the outer shell of the
Outer shell.
this thing, outer shell.
Yeah.
So
Yes.
and
Uh,
this cause release of some energy which is in
So
form of
when the outer shell electron comes inside, that he has to release that energy because he's coming from the higher level to the lower level. So from coming
correct.
to the higher level to lower level, he has to release his energy. That energy is measured with the detector. So that is actually we
that
call it the
that
secondary
energy is
X-rays.
basically measured by our detector, which is in form
Yes.
of this peak which is generated here.
Yeah. Correct.
Okay. And this shifting of releasing of energy from outermost cell to innermost cell is called basically fluorescence effect, and that's why the name of the machine is energy dispersive X-ray fluorescence, right?
Yeah. Correct. Yeah.
Thank
So
you,
coming to
thank
the
you.
next slide. Yeah. So this is our actually the basic diagram. What we can say our main principle and the main components in X-ray instruments. The first one is the X-ray, which we are discussing right now. The X-ray tube. Actually, this is the prime source where X-ray radiations are being generated. So main important parts. First one is X-ray tube. Then comes the shutter. The shutter actually you can say it's like a door, and it prevents the radiations to enter into the measuring chamber. Normally, what happens when you switch on the instrument, X-rays are always on. So when we have to place the sample, that can and that time also the X-rays are on, and it can also and you can also have an effect of that sample because X-rays are hazardous. So we can't directly place our means we cannot say that we directly should use the X-rays on our hands or on our ourselves. So for that prevention purpose, we have a shutter, and it's like a door. And when we start the instrument, we close the door, and when we start the instrument, then only the shutter gets opened and the X-ray falls on the sample. The third part is the primary filters. The primary filters actually it is used for depending on your applications. Normally, it observes and what undesired whatever the undesired radiations are coming from the X-ray source. So it observes that and it gives you exactly what is required to the sample to get the more information from the sample itself. Then the fourth part is the mirror. The mirror reflects the image to the camera, and you can exactly see the location where exactly my sample is and where exactly I need to measure my sample or where exactly my testing has to be done. So this the mirror reflects that image and it gives to the camera, and we can place the sample as per our requirement. Then the collimeters is as per your sample requirement. It's always recommended the better, the bigger the collimeter, more information you will get. But yeah, in case you have a very small area, then we have to choose a small collimeter. We have the option of polycapillaries also. So depending on your requirement, we can choose the collimator size. And after reaching this X-rays to the sample, it gets excited, and that energy is measured with the help of detector. Detector sends the signal to the software via DPPP and gives the information for the composition of the sample, whatever the coating or composition is there.
Right. So this is basically the inner anatomy of our machine, that it functions with all those accessories. It have all those accessories like X-ray tube where X-ray get generated. There is a shutter. Shutter is basically the this safety media which do not permit the X-ray to come out. It always closes. It's only open when we actually start the sample. Then there is
When we start the
primary
measurement, yeah,
filters are
correct.
there. It filter out the, yeah, and then mirror is there. Mirror is basically to for the camera purpose. So and after that the collimator. Collimator is basically the spot size where we want to bombard the X-ray, right? So then that X-ray falls on the sample, which is mentioned in the top bottommost corner. And there, that atomic, when X-ray comes to your sample, and at the atomic level, like what Ajay explained in their previous slide, that at atomic level, that electron shifted fluorescence effect comes, and that's why peaks and things are generated in the software. So this is what the basic anatomy of the machine, which is inside the machine, how it works. So these are the basically briefing of the each and every parts, how it works. Fair enough, sir.
Yeah, we can continue with the next slide.
Yeah,
Then we can see the exact parts. We can go to the
yeah,
close to the exactly the what is the X-ray tube. The main important part for the X-ray instrument is the X-ray tube, and this is the where actually we get our radiations, where we develop our radiations. And depending on the applications, we recommend the different type of X-ray instruments and different type of tubes. Normally, for normal applications, if you have mainly the basic applications, I can say the basic applications are like if you have a zinc coating, if you have a tin, say about one layer or two layer of type of coatings, if you are doing nickel zinc, then we can do the applications with a standard X-ray tube. And if you have a little bit of more complicated, then we can have an option of microfocus tubes. Then we have a tubes with which can have polycapillary also, and now we have also the tubes which is having the chrome anode as well for very light elements. And basically, if you see the picture here, this is the X-ray tube from where we actually generate the radiations.
correct.
Coming coming to the next slide, the other components what we have discussed are the primary filters. Uh, from the first image, you can see this is the filter here. This is actually shutter. The filters are also fitted inside the shutter itself. And the primary filters and shutters are already discussed. The primary filters is required for to means in case we have undesired radiations, we can it observes that undesired radiations. And when we have the shutter closed, means we have to place the sample. We can just keep it off in on off condition so that the X-rays which are bombarding will not affect you. Then for your image other things, we can have a video camera and mirrors so that we can see the image exactly where the sample is to be placed and where we need to do the testing. So these are the
Correct.
components which so these are some main important parts. First one is the X-ray tube, then the filters and the shutter. The filter and shutter is actually this is the first image you can see is the shutter only, and the filters are placed inside the shutter. Then this is my camera here to check the sample. Then here the third image from this side where I placed my cursor, it is the mirror. And this is the back side of the camera where when we need to check the exact location of the sample. Then the other part, again, it's very important. the collimator, or you can say aperture. Depending on your sample, depending on sample location, depending on sample size, we recommend you the collimators. As already discussed, we have a single collimator option. We have a multiple collimator option where we can choose the instrument which will have collimators, say from 0.1 also, or lesser than that. We can give you collimators with a rectangle shape. We can give it collimators for square shape. We can give you a collimator up to 3 as well. So depending on your requirement, depending on your applications, we can have a different type of collimators. And in case you have a coating very less, then we have the instruments which we have option for a polycapillary also, where we can go to very low level to up to 220 nanometers.
Okay, okay. In nanometer itself.
Yeah, in case say in PCB applications, or in what you could say, we will discuss in when you have electrolysis nickel in PCB applications, then we can choose the polycapillary instruments. And where the sample spot or the sample spectral size very slow, we have these instruments which have a polycapillary, and we can go down to 20 nanometers as well. Sorry, 20 micrometer size as well.
Okay.
Then comes this the second, we can say in that particular way, that X-ray tube and the detector is the most important parts. The other parts are also important, but yeah, this is the main important part. This is the heart of the instrument, or a brain of the instrument, the detector. And normally detectors are used for measuring the task, which is actually measuring your radiations level. And Fisher provides you three different type of detectors depending on your application. We provide you the proportional counter tubes. The first image is for proportional counter tube. Then mostly required for basic applications, and you have a thicker coatings also, because spot size here you can say the area wise is the area spot is very big. Then in case you have more complicated applications, we can provide you the silica pin type of detector, which can do the material testing and coating thickness as well. Then the highest and the top end model, which is having silicon dip detector, you can call it a modern semiconductor type of detector, which is having more performance for lighter elements as well. So Fisher family provides you all type of application coating applications, where we can have a proportional counter tube, we have silica pin detector, and we have SGD type of detector. Yeah,
So
Yogesh?
this is the only three kind of detector which is available in the market, or there is some another detector also?
No, practically you will have only three type of these detectors, depending on your application. If you have a basic requirements, then you have a proportional counter, which will certify your all, which will give your whatever type of coatings you have. So you can choose the basic one, the proportional counter one. Then if you have a mid one, you want to do the composition analysis as well, and you want to do the coating thickness, then we can choose the mid top instrument, which will have a silica pin. And if you want to do the coating thickness from aluminum itself, then we can choose the silica dip detector. Then yeah, we have an option in case say we wanted to now, there's a requirement to check the analysis of aluminum as well. We have want to go from sodium, magnesium, then we can use the same SDT type of detector, and we need to add vacuum or helium purge there to create an innate atmosphere, and we can do the testing composition analysis from sodium itself.
Correct. So we can say that silicon dip detector is the most advanced detector in the world, which is available for X-ray testing.
Yeah, correct. Yeah.
Okay. Okay.
Yeah, as already discussed, the proportional contact detector, uh, actually, it can it can have counts up to 10,000. You can means you can tolerate up to 10,000 counts. Energy resolution is approximately 900 electron volts. Normally, it can be used for routine applications, like if you have a nickel zinc coatings, you have a tin coatings, you have basic applications like nickel zinc, you have tin lead alloy. Then we recommend you these proportional counter instruments. Mostly when we have customer requirement is for a ROS RHS testing. He wants to do the nickel phosphorus with along with the phosphorus percentage. Yeah, we can do with the professional counter in case the customer requirement is on ferrous base, but in case we want to run it for coating thickness, and normally for coating thickness we can do it for using professional counter instrument when he is required for phosphorus percentage as well. Then it's better to have silica pin or SDD. Coming to the next one, silica pin can handle up to 1 lakh counts. Uh, with a smaller entry window. Energy resolution is approximately 180 electron volts. Normally recommended for complex applications, like you have very thin coatings, you want to do the gold analysis, if you have want to do some typical layer of typical type of applications where you have multiple layers, then also we can recommend silica pin. Then the best part is SDD1, which can handle up to 5 lakh counts per second. Energy resolution is very less, 140 electron volts. That means there will be no such loss in the energy. You will even absorb. You can detector can take very less counts as well. Typically recommended for all type of applications, whatever applications the customer has right up to the market. It can handle any type of applications. Like you can do the gold analysis, you can do silver analysis, you can do the trace and wet analysis, you can do nickel phosphorus coatings, you can do a ROS applications. Whatever type of applications you have, you can do with SD type of detector. So basically, as discussed, we have a basic one which can handle up for basic applications, which can handle up to 10,000 counts. Then we have silica pen which can handle up to 1 lakh counts. Then we have SDD one which can handle up to 5 lakh counts.
Right. So the SDD detector have the most, most advanced detector since we have discussed, and it have the most capability of 5 lakh counts per second in a smaller window.
Yeah, correct. So
Okay.
yeah, if I was just adding the next slide, and later on I will go back to the previous slide. If you see the applications covered here, so most of the applications can be covered with the help of SDD1. So if you have a normal applications like you have aluminum ferrous, we can choose proportional counter also, we can choose silica pin, but I can say yeah, SDD is always better. But yeah, I cannot say that proportional counter will not do that application. Yeah, we can do that basic applications from proportional counter as well. Silica pin also will do the application. Then SDD is better. Then if we choose the gold, nickel, and copper, or you have a gold and copper base, professional counter will also suffice your application. Silica pin will also do the application, but SDD is always better. Then if you have say a zinc coating, or zinc on ferrous on, or either zinc on a different type of ferrous alloys, a professional counter will also work, silica pin will also work, and SDD is always the better option. Coming to the other applications, like if you have a nickel, if you have nickel zinc, you have zinc tin, you have silver coatings, you have tin coatings. The professional counter is also doing an application. You can check with the professional counter instrument, you can check with silica pin, you can check with XGD. If you have a decorative type of coatings like chrome, nickel, copper on ABS, as professional counter will also work, silica pin will also work, and SGD will also work. For solution analysis, uh, uh, professional counter will can go down up to 1000 ppm, but if your range is very low, you want to check up to 100 ppm, then silica pin or SDD is the best instrument where you can go down up to 100 ppm. When your requirement is up to solution for solution analysis, if your requirement is up to 1000 ppm, then you can do with professional counter as well. uh, Say you have some special applications, in case you have, just like I discussed in the previous slide, if we have nickel phosphorus and only we want to measure thickness, so professional counter will also work. But if you have a requirement of nickel phosphorus with phosphorus analysis, then we have to go with SDD only. For special applications, like if you have RHS coatings, you want to check RHS screening, then only SDD is recommended. If you have a nickel phosphorus on aluminum base, then SDD is already the only instrument which is recommended. If you have a nickel phosphorus on copper basis, uh, even though then SDD type of instrument is recommended. If you have a hard coatings like if titanium nitrate, tungsten nitride, or if you have some other type of hard coatings, it's always better to go with SDD type of instruments.
So this is what some application based how customer can select their detector based on their applications, right? So if
Yeah,
customer have a basic application like checking aluminum on a single layer, if you can say, so proportional counter will serve the purpose. If they have some complex kind of application, then silica pin is okay for that. And if customer have some specific special applications like ROHS testing, heavy elemental analysis testing, or to check very close elements like copper, nickel, which is close in energy, and that is on brass or again copper. So those complex kind of application could be only possible through the most advanced detector, which is SDD. So based on their application, customer can choose their detector, right, sir?
yeah, correct. So
Correct.
I'm just coming back to the previous slide, what we have discussed. Say if you have a proportional counter instrument, I can say, yeah, the price wise it's perfectly good. Silk pin is a little bit costly, but
Oh, yeah, I
hello.
should. Yeah, I should actually. Yoganand just attended. So Yoganand, could you please make your this thing? Yeah, thank you. Yeah, please go ahead, sir.
Yeah, so price wise, I can say the professional counter is the best option where you don't have to pay that much. Professional counter is a little bit higher side, but SDD will be always in the higher side. But resolution, as if you compare the resolution of the sample, the professional counter instrument PC counter detector doesn't have that much of good resolution. As discussed, it is having an resolution approximately 900 electron volts. Silica pin will be having approximately 180 or 190 electron volts, but SDD will have very low 130 to 140 electron volts. Coming to the active area, professional counter is having the big active area. So in case you have thick samples, you have samples with large areas. So we can also recommend a professional counter instrument. Silk up pen is having not that much of big area, but Silk up SDD will have the two options. We can give you 20 we can give you 50 column in the active area size. So for active areas, professional counter and SDD is the best option. For count rates, as I already discussed, for count rates, the professional counter can handle up to 10,000 counts. Silka pin can handle up to 1 lakh counts. SDD can handle up to 5 lakh counts. So that means when NB comes to the energy resolution, and as already discussed, Yogesh was telling, when we have very close elements and we want to check the combustion analysis with very close analysis, like nickel and copper is very close to each other, and if you have a base of brass, that means the base will also have a copper and zinc. So you need a very sensitive instrument. So that time you need to have a very good count rate. So for this type of applications, I will recommend you have SDD type of instrument. And coming
Yes,
to the
I think.
stability,
Yeah, actually, meanwhile, I'm running some polls also, sir, just for your information. And
okay,
customers are giving right answers related to the detector and these things. So yeah, I think they are getting
okay.
what we are want to convey actually.
Okay, fine, fine. We can continue
Yeah,
that one also. Yeah.
yeah,
Coming to the next one is the stability. So in case of stability, we say proportional counter is also a stable type of instruments, but we recommend, so whenever in the morning you switch on the instrument, we would recommend to have at least warm up the instrument for 5 minutes, then start the test. But for Silka pin or SDD, it doesn't have to worry about. You can switch on the instrument and you can just do a warm up of 1 minute, and it's more than enough, and you can start testing. And for ROS elements and trace elements, as already discussed, proportional counter can handle very less counts. So we don't recommend the proportional counter instrument for ROS and trace elements. We normally recommend for ROS, we recommend SDD. For trace elements, we can go for Silka pin as well. Precious metals also, if we have a precious metals, then also we recommend to go with SDD or Silka pin. But yeah, we can check with proportional counter instruments as well. As we have already discussed, the professional counter instruments can do the analysis from titanium, that is atomic number 22, to uranium. And silica pin can check analysis, material analysis from either, if you have SDD type, it can go from 13 number, or to, if you have silica pin, SI pin, it can go from 16 to uranium. When the same instrument SDD type, if we add vacuum option, or if we add helium purge, we can make an inert atmosphere in the sample chamber, where exactly we have to measure our sample, and we can go very low level up to sodium itself, and we can have a very good accuracy level for these light elements. Say example, if you want to check aluminum, you want to check silica, you want to check magnesium, then we recommend to have SDD detector with a helium purge option or a vacuum option, where we can remove the air from the chamber, because air also contains the gases which will absorb your electrons which is coming from the sample, and it can just reduce your count rates. So to overcome this type of problems, we can have a vacuum option, or we can have add up a helium option, and we can do the analysis from sodium itself.
So basically, the most advanced detector what we have, we can cover the elements from sodium to uranium. I mean, from lightest element what we can detect to our instrument by using all those the special atmosphere like helium or this thing, and
Yes,
by
yeah,
using
yeah,
most advanced
yeah.
detectors, so the most lightest element what we can detect, it is from sodium.
Sodium, yeah. So normally what is
Yeah.
there, if you have lighter than that, then it is neon is a gas, fluorine is a gas, oxygen is a gas. So lighter element, if you say it's sodium only, and most of the people are looking for the elemental analysis from sodium itself. And we have the options where we can have our instruments with both the options can be provided. We can do the testing in air mode and normal operation, and we can have the same instrument which can work in helium purge, or we can add up the vacuum option there, and we can do the trace elements from sodium itself. Normally, there are a lot of influences when we take the measurement, and the results are getting affected by the different type of parameters. And the one of the parameter is the depth of penetration. So if you have a coating, say example of you have a coating of gold, or you have a coating of silver, and you have a coating of tin, say approximately you have done the gold coating of 8 to 10 microns, and X-ray has the penetration power which can go up to the depth depending on the density of the material. Say example, if you have example, you can see the image here. And the copper can be penetrated up to, from here you can see from the image itself, the copper can be penetrated up to 35 microns. So if you have a coating greater than 35 microns of copper, then you have a second layer. Then the X-ray will not penetrate to the, it will not go to the second layer. It will not give you the complete information from the second layer. It will only give the information of the top layer, because your penetration for the first layer is itself is a up to saturation level.
Correct.
A say example of silver can be checked up to 75 microns. And if you have a first coating is say 70 microns, and below that you have copper layer, on base maybe aluminum or any other material. And if you have done the first coating, the top layer is itself is at up to saturation level, then the X-rays cannot penetrate to that the high density, and you will not have the signal from the second layer. So normally, for these type of applications, we don't recommend XRF instrument. We can have some other solutions. We can have a beta scope instruments for these type of applications, where we have a coating more than, if you have a silver more than 70, 80, 90 microns, then we recommend you to go with a beta type of beta scope type of instruments. But when you have a coating lesser than that, we can choose this type of ED-XRF is the best solution for this type of applications. And mostly depending on your depending on coating and coating material, we can give you the exact information about the sample penetration limit, or sample saturation thickness, and how much the signal can penetrate.
Okay.
The other parameters which influence while we do the sample testing is the sample positioning. Normally, what we get a complaints from the customer that we are not able to get the proper result, or maybe some it's giving me error. So that can be reason because the sample is not placed properly, and it is not facing towards the detector. It is placed in such a way that the signals are not reaching the detector. It is getting hit by the sample itself. So these things has to be taken consideration when we place the samples, when we run the test. From the figure itself, the shadow effect also it plays the role. So when you place the sample, you check exactly the location where the detector is there. So in that particular direction, you need to key the sample, and you can give 100% accuracy of the sample results.
Correct.
The other advantage what Fisher has, we our instruments has a PCM method that we call distance control method, and it's our patented technology. If your sample is of a different size, and you want to measure them simultaneously, so we don't have to remove the samples, and we can autofocus them, or we can manually adjust the samples. See, if your samples are different size, say one sample is approximately 1 other is approximately 20 and within this range our instruments are pre-calibrated. So if your sample height is up to 20 you want to measure the sample at 15 or you want to measure the sample at 10 you don't have to change anything, just autofocus it or focus it manually. You will have the same results with either sample is placed on the flat area, or it's placed on some particular height, or the sample is not in the same geometry. It can be a complex shape samples, and it can be have any type of trigonometry. So up to 25 or some instruments we have 80 also. So depending on requirement, depending on application, depending on sample size, we can recommend you the instruments. So we don't have to worry about the sample position, the sample geometry. You can do any type of samples easily with this patented DCM method.
Correct.
uh, um, I'm not getting out of time, or we are on time?
We are a bit slow, I guess, sir. It's already 47.
Okay. Okay, we can move a little bit faster. Coming to the
Yeah.
next slide, we have a measuring time also affects on the sample analysis. When we run the tests, we recommend you have, if you want more precision, you want a good repeatability. So I will recommend to have a little bit of more timing to give to so that signals can reach the detector, and you can do sample testing approximately. I will recommend to go, in case of coating analysis, I can say 10 to 30 seconds is more than enough. For material analysis, I will recommend 30 seconds is more than enough. Even if you want more accuracy, 60 seconds will give you 100% repeatability. But in case we add more timing, that is not going to help you out. 60 seconds is the saturation level where you get 100% accuracy of the sample results. Then coming to the advantages, XRF, there's no adverse effect on the sensitive material. You can have take your samples as good as new one only. Quick measurement time within 30 seconds or 60 seconds. You will have a analysis results. Easy to use and can be operated in a simple basic training. There is no complicated software. It's very simple. Any person who knows a little bit about computer can work on this instrument. High precision and trueness is there. You can have a very good accuracy level, very good repeatability. You can check your samples 100 times. There is no sample preparation required. You don't have to dilute the samples. You can just bring your sample from the factory itself and check the coating and give the feedback. Safe method without any hazardous chemicals. Nothing, no chemicals are used for testing purpose. Inexpensive because no consumers are there. Standard free and calibrated analysis can be done. So our Fisher instruments, if we do the testing without any calibration also, our software is that much powerful that even though we don't do the calibration, we can have the accuracy up to 95%.
Okay.
To make your business profitable, we recommend you to have a XRF, so you can improve your electroplating quality by reducing the customer complaints when you are giving the samples to the third party, or you have to do your OPMs, OEMs, and they are They are rejecting your sample because of your coating is less or because your coating is more. So you can check it out the before sending the samples. You can check with your X-ray instrument, and you can assure your the coating is perfectly in line. So even though you can do the incoming inspection, if you have a third party suppliers, and I and also can say that if you have a very good calibrated instruments, you can reduce your losses by giving extra means of plating. See, if you are doing precious metals, if you're doing gold coatings, you are doing silver coatings, and your coating levels 1 micron or zero point 0.5 micron, and honestly you don't know exactly how much micron you are doing in that particular time. So unnecessarily you are giving, instead of 0.5 microns, you are giving 1 microns. So that cost can be saved by checking, continuous checking with the X-ray instruments, and your cost of the instrument can also be covered in within 1 year if you maintain this type of platings. You can recover your metals from the solution bath analysis. You can do your solution testing to ensure the bath conditions are well maintained. We can do the material composition, we can do RHS screening, we can generate our reports, and we can save the reports for future considerations as well. I'm a little bit fast now.
So, meanwhile, that ED-XRF machine can do plating thickness analysis, can do chemical composition analysis, elemental analysis, and can also do the RHS screening, right?
Yeah, correct. So if you see the advantages here, the single instrument can be used for elemental analysis from aluminum to uranium. We can do the multiple layer coatings, we can do composition analysis, we can do the bath solution analysis, and RHS screening can be done. Means you don't need to send your samples for third party to check if you're exporting your samples. No samples has to be done. In case it is failing here in XRF, then only you have to check. You need to send your sample for third party inspection. As already discussed, very easy to use, very accurate, very precise. You can have any type of coatings, metal coatings on any type of substrate basis. No sample preparation. You can have samples can be checked at multiple locations. Uh, um, you can generate your reports. You can check the coatings, very thin coatings, and into nano range as well. And you can have, if you have a very small area, say you have 0.1 or even smaller than that, that also can be done easily. The only limitation with XRF is if you have a very thick coating, you are doing very thick coatings. The example I have given you, if you are doing copper layer of greater than 40 microns, then the X-ray will not penetrate from the first layer, and you will not have a composition analysis or the proper signal from the second layer or the base composition. Coming to the applications, industrial applications, plating, galvanizing, and material analysis, the automotive is there. We can have applications for automotive industries. We can have application for solar industries. We can do application for connectors. We can have hard coatings like PVD, CVD, and DLC. We can provide a solutions for aeronautics, aerospace, electronic industries, golds, watches, and jewelry. As already discussed, we can do the material analysis and RHS testing. Sorry. Recycling of the samples can be done, and general plating, any type of coatings can be easily checked. Say if you have you want to control your incoming components. So you are doing coating of zinc nickel, geomet coating, or zinc flakes, can be easily checked with XRF. If you have a galvan sheets, can be checked with XRF. You have a nickel phosphorus coating, sorry, with nickel zinc and zinc on fasteners, can be checked with XRF. If you have electronic components with tin coatings or nickel coatings or gold coatings or gold platinum nickel coating lead frames, can be easily checked with XRF. ROS can be done. Sorry. If you are doing decorative coatings, like you are doing chrome nickel step on copper on ABS, if you are doing step, then we'll recommend you to go with CMS instrument, which is a destructive method, which can help you give you information regarding the step application. Solutions can be done with XRF. Hard coatings like PVD, titanium nitrate, and any other tooling watch industry can be checked with XRF. And if you have incoming inspection for the paint coatings, we have the instruments like TFTs, which can check your paint or analyzing other things. And if you want to know the paint properties, then annotation can be helpful for you. Coming to the automotive and electronic auto component industry, is from the figure itself, we can see most of the components are coated now. So application wise, you can say zinc coating is done on the cap, so that can be checked with XRF. And if you see the spokes is zinc plated, you can see the shock absorbers are mostly chrome nickel step coated, so can be checked with the CMS instrument as well as XRF instrument. If you have a headlight that is chrome coated with nickel step, or if you want a total nickel, if you want total nickel, we can check with XRF. If you want step, then we can check with step instrument. uh, any type of coatings in automotive industry can be checked either with 99% can be done with XRF, but we have solutions for other applications as well. In aerospace and affiliated industries, checking the electric conductivity, we have electric conductivity instrument, and anodizing can be checked with DFT instruments. Paint on aluminum can be checked with DFT. Moly coats can be checked. Cadmium on aluminum die cast can be checked with XRF also. Zinc nickel can be checked with XRF. Nickel phosphorus with phosphorus percentage as well can be checked with base with SD type of instrument. Nickel phosphorus on ferrous base can be checked with proportional counter as well. And you can, if you are mainly interested in phosphorus composition, then we'll recommend to go with ferrous SD type of instrument. Hardness properties can be checked with a nano addition system. In electronic connector industry, PCB applications, wafers, LED frames, photovoltaic applications, XRF is the best solution for these applications. Like you have a LED frame application, gold, platinum, nickel on nickel and copper. If you have a gold, nickel and copper alloys, if you have a gold, nickel, phosphorus and copper alloys, if you have a thick tin on nickel and copper on MS, and if you have a nickel, copper, zinc on, or copper, beryllium, or copper, nickel, XRF is the best solution for these applications. If you have a tin copper on PCBs, can be checked with XRF method. And for wafer applications and photovoltaic applications like aluminum on titanium tungstite and silica wafer, XRF is the best solution. CIGS applications, we can go with the RHS, and RHS can be checked with XRF instruments. I hope everything is clear. Can I continue, or little bit
Yes,
slow down myself?
it is very much clear, sir. It is very much clear. I will take the question of customers in the end of 5 minutes, I guess. So you can continue with your PPT, sir. Yeah, we'll answer the questions
This one
in the
already we
end
have
of 5
discussed. Yeah, we already discussed this slide. In case you have interest in phosphorus concentrations, then best recommended is to go with SD type of instrument. And if you want to do the very low range, then we will recommend to go with a instrument which is having the vacuum option, or you have a inert atmosphere option where we can insert and a helium gas there. For PCB industry also, if you are measuring the phosphorus content under the gold or platinum, non-destructively, we can use XRF instruments. Gold platinum coating on nanometer range in printed circuit boards can be checked with XRF. Thickness of conformal coating can be checked with DFT. We have a special probe for that applications. And if you want to measure the copper coating inside the through pinholes, for that also we have a special probe. We can check the copper coatings on the pinholes. And if you want to measure the solder resist in printed circuit boards, then we can recommend you to go with CMS instrument, or you can have XRF instrument for this application. And if we are doing electros nickel with immersion gold, ENIG, if we are doing ENEPIG, electros nickel with electros platinum immersion gold, then also that applications can be checked easily with Fisher XRF instruments. For decorative coatings, watch industry and hard coatings, like application for a decorative coating, chrome, nickel, copper on ABS can be checked with XRF. And can be for in case you have chrome nickel step, then can be checked with CMS instruments. Gold on hard on SS bases like watch industry can be checked with XRF instruments. Gold and titanium nitrate on nickel, on copper and alloys can be checked with XRF instruments. Gold and hard coating zirconium nitrate can be checked easily with Fisher XRF instruments. Gold, platinum, nickel on copper on SS can be checked easily with XRF instruments. Hard coatings like DLC or titanium nitrate, DLC can be checked with the DFT meters, and titanium nitrate can be checked with ED-XRF instruments. As already discussed, RHS can be done with ED-XRF instrument as per the IEC 62321. We can check major all elements which customers are interested, like lead, that is having the tolerance range up to 1000 ppm. We can go for mercury, chrome. We can have a bromine, and we can do cadmium as well, which is having the tolerance up to 100 ppm only. So can be easily checked as per your requirement. We can do for metal analysis, metals. If you have plastic materials, if you have like coated samples, for that any type of application, we can do the ROS analysis testing. Fisher provides any type of standards whichever is required as per DKD certification. Our Fisher is certified as for mass per unit area, and this is the first ever lab in Germany which was certified for uh, DEX certification. Since 2003, our Fisher is accredited for the certification of standards, which is helpful for the customers in case the customer requires any type of coating application, has any type of coating application, requires some coating standard for that application. And Fisher can provide the solution for that with the standards, whatever is required for that application. This is the basic one where we just wanted to know how to switch on, how to actually basic training for switch on the instrument, switch off the instrument. If you see from the, if you are known to the Fisher instruments, we provide a main switch from the left side of the instrument, and when you need to switch on the instrument, you can just press it down the switch from the left side. Then in the front of the instrument, you can see the push button. So after switching on from the left side, you can power on from the front button, and the instrument will get on. After getting on, you can switch on the instrument PC, and the PC will get started. Then the WinFTM software icon is there. You can double click on that one, and it instrument gets initialized, and you can see the uh, communication symbol that it is being communicated with the instrument. In case we have to switch off the instrument, it's better to first just close the software first. Every time in case you have to shut down the instrument, it's always recommend don't switch off the instrument first close the software, then shut down the PC, and you can then switch off the instrument again from the right side with the power on off button. And there is a key, if you key there for the safety purpose, in case you don't want any unauthorized person to switch on or switch off the instrument. So you can switch off that key and take it off, and take it off from the panel, and there is no unauthorized access, so that no one can interrupt or no one can unnecessarily switch on or switch off the instruments. Regarding the environmental conditions, I will say power supply should be always stable. You should use 230 volts with 50 kilohertz frequency. Earthing should be proper. Before switching on the instrument or before installation, I will recommend you have your electrician, have your technician, company technician, or you can call our service engineers also, and you can check earth and neutral voltage, and it should be always less than 3 volts. Yeah. And the environment, the lab exactly where you are placing the instrument, it should be dust and fumes free. Temperature should be maintained, humidity should be maintained. The instrument should be placed properly in AC conditioned room, and placement should be it should be in a proper way so that you have enough space so that the airflow can be have from the either side of the instruments. And one more recommendation from the service team is that don't just place your instrument below the air conditioners. So, coming to optimization of the instrument, Yogesh, I'm there.
I recommend, sir, optimization is not that much of concern, because what we are discussing
Yeah,
about this
yeah,
thing. So
We can, yeah, that's what I was discussing. The main important parts, the main in the toolbar is MQ value. And the MQ value actually is the measurement quality value. And normally we recommend when you check the sample testing, you can see from the image also, if your values are coming from 0 to 5 range, the this means the measurement is perfectly okay. And if it is going more than higher level, greater than 5, then I will say there's some deviation in the results. So you can have to check the either the application is wrong or sample is wrong, or what some issue with the instrument also can happen with there. But most probably you will have some wrong application chosen, or some wrong base material has been chosen for that application. That's why it is giving the MQ higher MQ value. I will skip these slides right now. I will choose some important ones only. If you have to delete the readings from the evaluation, you can have the option of delete readings, delete one by one. And if you choose all the readings to be deleted, you can undelete all the measurement data. And if you have deleted some of the readings, you can undelete them. You can have an option of undelete. You can check, you can retrieve that data. And if you want the save your uh, sample information, we have an option of order number. You can give the sample information, you can export your files, you can set up a print form, you can block report, and you can have a final report as well. And from the general menu, you can have a communication on off. You can switch off the communication, or switch on the communication. You can save your spectrums, you can take the reference measurement, and you can go to the service options also. Service option is available in service option in general category, where you can check the test of stability, the instrument is perfectly stable or not. Or you can have the service status display as well. Running the test is okay for everyone. I can quit this slides. So coming to the last one, this is our Fisher Signaling office, where we have our R&D center, we have our sales office there, we have our production department there, and 70% of the people are working for R&D department there in Signaling. Fisher is a leader in supplying the precise and innovative type of coating instruments for material analysis and micro hardness testing of instruments. We have a headquarters in Sindelfingen, Germany, and approximately we have more than 22 offices worldwide, 80 distributors, and 500 more plus employees worldwide. Uh, Fisher has a presence everywhere in the world. We have office in Switzerland. We have office in Germany. Headquarters are already in Germany. We have office in England, France, the USA, China, Korea, Taiwan, Thailand, Japan, and we provide the solutions as per your requirements. All subsidiaries are certified according to 9001, 2008, and all companies have sales, service, and application support. All services are provided within 3 to 48 hours. In Fisher, India, we have headquarters at Fisher, Pune. Then we have assembly plant also for jewelry jewelry section in Pune itself. Then we have office in Delhi for north. We have office in Kolkata for east. We have office in Bangalore and Chennai for south team, and we have office in Ahmedabad for our west division.
yeah,
Why partner with Fisher? Fisher is a global company with a local support. We provide you the traceable result standards with DEX certification, and national presence with national presence with sales and service support. You can have your total cost of ownership. You have a security of your investment, and we can run your samples, and we can know your applications first. Then only we will recommend your instrument for that particular applications. Coming to the partners, Bosch is our partner, Coventia is our user, Grovel is our customers, Volkswagen is customer, Dalmer is our industrial customer, Autotech is our industrial customer, Bajaj is our customer, Mahindra is our customer, Rolex are Fisher instrument users, Bosch is Fisher instrument users, Honda is Fisher instrument users. And if you want, you can also visit our sites via LinkedIn. You can note down these LinkedIn sites, and you can visit on LinkedIn, you can visit on YouTube, you can visit us on Twitter, or you can also follow us on Facebook as well. Thank you. I'm taking a little bit of more time. Thanks a lot.
thank you, sir. Thank you. I mean, it's good to be. Though we have skipped some of things, but I think it was a bit of a user interface kind of thing of software basically, and the customer who are already using our instrument, if they found any difficulty, they can directly contact us. They can directly contact to the service engineers. They are right away at your doorstep, just one call away. So yeah, now I think we have covered the entire part, what we have planned in the beginning, like to know the basic idea of XRF, how it works, what is the basic principle involved, what is the science basically behind the working of ED-XRF machine. And at the end of this session, I think I have run some polls also, where I think customer have given the very right feedback, and on the basis of that, I could say they have understand the basic things of the XRF machine, that how it works, what parts it's involved, and how that parts are playing role in the selection of XRF machine as per their application. So I think it was well enough, sir. Your briefing was very quite informative. Now I would like to have some questions if customer have. I think I already have 7 to 8 questions, so which I put in front of you, and I'll also try to answer some of it. So yeah. So first question, what it comes from uh, Mr. Vipul Sawant, what will be the use of this machine for in service underground pipeline when exposed? So I think Ajay sir, you could better answer this. So I think what
Yeah.
he want to convey, that he wants to inspect the service related thing for the underground pipeline. So I think it is not related to this X-ray machine, because it is a laboratory based machine which is kept as a benchtop model, not for the on-site application. So definitely a
Yeah, but
big no for this
yeah,
kind
I
of
will just
application.
interview in between. In between, I will just interview in between. If you can check with the customer if he's having some particular type of coatings there, then we can also check as actually what application he is doing there, and we can recommend him the
Yeah,
DFT
we
instruments if he is having the thick coatings. Yeah, we can recommend him a portable XRF if he's doing some metal coatings also. You need to check with
so
the customer.
yeah. Second question, what it is, share the design number by which we can check coating hardness. So
The coating hardness can be checked with the nanometer type of instruments. We have different type of nanometer depending on your coating, how much coating you are doing. Say we have nanometer which can go up to 2000 millinewtons. We have an instrument which can go up to 500 millinewtons, and depending on your particular coating thickness, we can define the load. So if you have more information about your samples, you can share with Mr. Yogesh, or you can send samples to Pune. We can verify 1 or 2 samples of yours, and we can send you the report, and we can share you the brochures as well.
one question from Mr. Khalid Rahman is there, that how can we measure copper thickness when we have base material is copper alloy?
So if you provide us the exact base information, or if you provide us uncoded sample, we can check the composition, we can fix the base, then we can define the coating thickness. But if it is a pure copper, and that you have done the copper coating, then it's not possible with any type of application. But if it is a copper
It's a
alloy, as
copper
you
alloy,
have
sir.
mentioned, yeah,
The
then
base
definitely we
material
have
is
to
copper
fix.
alloy.
Then definitely we can set the base, we can define the base, and we can check the coating.
Correct. So I think if they have like brass is
Yeah,
basically a alloy of
yeah,
copper
copper
and
alloy
zinc.
only. Yes,
So if they
yes.
know I mean, if they have as a brass as a base on which they are doing copper, so we can fix up the base composition, and then we can check the copper coating
We
over that. I think
Yes, correct.
it is very
Yeah,
good.
yeah, 100%
Okay,
possible.
100% possible. Correct. Second is next is Mr. Pandian is there. So his question is zinc and zinc iron plating on iron base. So could it be
Yeah, that
possible
is
through
also
XRF
possible.
machine?
That is, yeah, normally these applications, this is our regular application, what we can check with XRF instruments. Zinc, iron, and on ferrous base can be easily checked.
Uh, Next question is from Mr. Sujit. Can you please share difference between XRF analysis and chemical analysis on the basis of accuracy? Yeah, sure. I'll share you that, because there are different methods for the chemical analysis. and how XRF machine is capable based on accuracy. And this thing I will share him, not an issue. Next question is from again Mr. Uh, Aluminium and silicon percentage in PVD hard coating can be checked with SDD detector.
Yeah, in case we are using instrument with a vacuum mode or helium purge option, then it is 100% possible. When we are using normal instruments, then thickness can be done, but percentage of aluminum and other properties cannot be done.
Okay, okay. Next is from Mr. Neeraj Beriwal. That again the same person. He's asking about titanium boride coating thickness can be checked with XRF.
Yeah, titanium accent is a hard coating only, and we can check with XRF.
Okay, okay, okay. Uh, sure. Next question is can we check internal metallic layer on tin? I don't know. Can we check internal metallic layer in tin wire flow process? I think Mr. Sumit Seth is there. His question is, can we check internal metallic layer in tin wire flow process? What is tin wire flow process? I don't know.
If he
But
wants to
can we
measure
check
in,
that internal
if
metallic layer?
yeah,
Yeah, we can check, I think.
we can check it out. Yes, it's possible. But if he wants in the
Hmm.
continuous process, we can have to then inline instrument option is there. If you want
Yeah,
to do the like, you can give a sample and you can check it in this lab, and whatever the coatings or whatever the intermediate layers are there, it's 100% possible. And you
correct.
can ask the customer the more information about the sample process, how he is doing the
Yes.
sample analysis. Yes, then we can
Yeah.
really helpful. Can really
Definitely,
help
we
you.
can measure the intermetallic layer up to 24 layers. I think we can measure the coating without destructing the coating up to 24 layers. We can measure whether it is intermediate layer, top layer, or bottom layer. Uh,
Yeah, depending on the
so,
densities of the material, correct.
yeah,
Yeah.
depending on the density, we can measure it. Yeah, but yes, customer have to give much more insight, like they have explained some flow process. So basically, we have
Yeah,
to go
correct. Yeah.
in depth with the discussion after this
We can
webinar.
come back to the customer. We can come back to the customer
Yeah,
and we can have more information from his.
yes. So next is how we can do coating composition with XRF. So I think we have already explained about the whole processes of
Yeah.
detection of chemical
So
composition
like
to
we have,
XRF.
if you
So
have a
better I
if
will,
we have a nickel zinc coating, say
yeah,
normal
better we
example is
can
if you
send,
have a nickel zinc coating, yes. Yeah.
yeah, better we can send this PPT him again, and he, though he came across some query, we can coordinate with him.
Yeah.
Oh,
Fine.
next good question is uh, for coating identification, are there guidelines to choose some specific filter for different coatings? Yeah, it's a very good question from Mr. Vidyanand Galpade. So, yeah, so uh,
Yeah.
for coating
Yeah.
identification, are there guidelines to choose some specific filters? I mean, in detection of the coating or its chemical composition, does any guidelines says about the filters to which
Yeah,
filter we
we can
choose?
say it
We should
practically. Normally, we have our R&D team, and they are continuously working on this type of things. And normally, we also provide different type of filters. Like we can provide you the nickel 10. We have aluminum 1000 filter. We have aluminum 500 filter. We can provide you the aluminum 100. And depending on what applications you have and which instrument you are choosing of, then depending on applications, we will see exactly where exactly we're getting more counts, more count CPS for more signals for your sample analysis, and we can recommend you the which type of filter or which voltage or which collimator is suitable for your application.
correct. Okay. What is the maximum thickness that can be measured through XRF machine up to 24 layers? What is the maximum thickness of 24 layers could be measured through XRF machine?
Yeah, that's why we, as discussed in the beginning itself, it depends on the density of the material. If your first layer is totally too thick, say your first layer is silver and you have done more than 70-80 microns, then I will not say it will go to the second layer. But if your coating is approximately 1 or 4 or 5 or 10 microns, 10 15 microns, then yeah, we can go say about 5 layers, 6 layers, 10 layers. It all depends on the densities of the material, which coating you have done and how much coating thickness you have done.
Correct. So if he wants, he can speak also for any
Yeah,
further
you can.
questions.
Yes, yeah.
So yeah, I think there are no more. How to place solution? Any SOP for that? Mr. Pandian is there. How to place
Yeah, we can
solution?
share. We can
Yeah,
provide them the. We can provide the video and we can send them the exact details how to run the solution analysis. If I think I understand the question properly. He wants to know how to do the solution analysis. Correct?
so no, he said that is there any standard operating procedures SOP is there
Yeah, that also
which
can be
guide
provided to the customer. Yeah, if we can share us the details of which model he is using, Fisher model he is using, we can send him the standard operating procedure of that instrument.
Ajay sir,
Yeah,
yeah, I think the question is how to place solution. Means I think they want to understand if they want to do solution bath analysis, then how we can able to check the solution, the bath. So I think it
yeah,
is like
to place solution. I mean, it's basically for the bath solution only. Is there any SOP to place the bath solution inside our machine?
yeah.
Better, I
That's
can.
why I'm saying we can we need to know actually which model he is using. So if it is a top end model, if it is a top to bottom model, we have to place the cell upside down. If it is a bottom side instrument, then we have to place from bottom side down. We have the SOPs and we have the videos for running the solution bath solution analysis. We can share with the customer, or you can directly get touch with you people or service guys. They can help him how to do the solution bath analysis.
Okay, 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 fair enough. Sure. I think we are over with our questions as well from the customer side. So at this note, I think we should end up our today's session, which is the online training session, chapter 1, what we have started. And we will try to make this sessions continue in coming days with chapter
Yep.
2 and 3, where we will cover the our other range of machines and instrument and take discuss about the the working principle, the science behind, and the user interface, how you would use do's and don'ts of those machines, and how you can explore different applications with our machines. So yeah, on these notes, thank you very much, Ajay sir, for preparing these
Yeah, we should
slides for
thank our
us.
customers also. We should thank
Yeah,
our customers who has attended our the seminar, and thanks
correct.
to all of them. And yeah, as Yogesh told, we will be coming up with other type of seminars. And depending on your requirements, you can mail to Mr. Yogesh what is your requirement, so we can develop the
Yeah,
presentations as per your requirements as well. Thanks all.
correct.
Thank you.
Thank you,
Yeah.
thank you, thank you very much, all attendees. If I will share you the whole presentation details and queries of yours, I can respond on my email ID. You have, I think, my email ID with you. So I'll send this link of this webinar in recorded form, and also this whole presentation in the PDF form. And though if you have any queries and concerns, you can directly write to us. We have a full-fledged team in all corners of the country. You can write to us. So yeah, on this note, we are closing our today's session, and we will come back again with another chapter of training, with taking the another topic and another range of machines. Thank you very much for attending
Thank
this
you.
seminar. Yeah, yeah.
Thank
Take
you
care.
all. Yeah.
Thank you, Ganan.
yeah. Thank you, thank you.